I'm R. Prabha, Assistant Professor in the Department of ECE, SNS College of Technology. In this video, we are going to discuss the topic on antenna parameters for the course Antennas and Wave Propagation. So in this video, we will discuss the topic on recall of previous topic, antenna radiation mechanism and isotropic radiator. Next, we see about antenna parameters. Finally, we are going to see the application part of these parameters and also the summary. So the antenna radiation mechanism is the antenna used as a device between to convert the incoming guided wave from the transmission line into free space wave at the transmitting side, and at the receiving side the free space radiation is received by the receiving antenna, which will be converted into a guided wave by the transmission line. It will be collected from the receiver. So, an antenna is defined as a transducer or transition device between a guided wave and a free space wave, and vice versa. So, next is the isotropic radiator. It is a hypothetical theoretical radiator, not physically exist, and it is used as a reference antenna to compare the physical antenna characteristics. So now we are going to discuss about the antenna parameters. So we will discuss in a design thinking way. So empathy, in the empathy part, the need of understanding antenna parameters is to know how effectively an antenna transmits or receives electromagnetic waves, and also these parameters allow the design engineers of antenna to design, analyze and optimize antenna systems for specific applications. So the first parameter in the defined part is the radiation intensity. So this will provide how the power radiated from an antenna in a given direction per unit solid angle, and the unit is watts per steradian. And here the significance of this parameter radiation intensity is engineers use this radiation intensity to evaluate directional characteristics of the antenna and also to optimize antenna placement for maximum performance in desired coverage areas. And there is an important formula to calculate average radiation intensity, which is the ratio of power radiated to 4 pi. So here 4 pi is the total unit solid angles in a sphere, that is 4 pi steradians. So next is the radiation pattern. This is another important parameter to know the characteristic of the antenna, because this gives how in which direction the antenna radiates more and in which direction it gives less radiation or zero radiation. So to visualize the antenna behavior, that is the antenna radiation characteristics, we can use this radiation patterns, and there are two types of radiation pattern. It is a graphical representation of radiation either in terms of electric field strength or in terms of received power. So if the radiation pattern has drawn with respect to field strength E volts per meter, then the radiation pattern is called field pattern. Suppose if we draw the radiation pattern in terms of its received or transmitted power, then the radiation pattern is called the power pattern. And also the other types, omnidirectional patterns, directional patterns. Omnidirectional patterns are the patterns which are obtained when the antenna radiate equally in all directions, and in the directional patterns they concentrate energy in a particular direction. And now the second is gain and directivity, which is the ideate part. The directivity quantifies how well an antenna concentrates radiated power in particular direction or desired direction. So this will be given by the formula D is equal to 4 pi maximum radiation intensity divided by power radiated. And the next important parameter is gain related with the directivity, and gain accounts for both directional properties and also the antenna efficiency. So it represents the ratio of radiation intensity to that of an isotropic antenna with the same power input power. And there is an important relationship between gain and directivity. That is, gain is equal to eta d into capital D. So this eta here is the efficiency factor of the antenna, and higher gain antennas concentrate more energy, and because of this we can use the antennas for long range communication, which reduced transmitter power requirements. And the third parameter we are going to see is front to back ratio. So in the front to back ratio is the ratio of power radiated in the front direction and to the backward direction. So the maximum power forward direction is the front direction, power radiated in the main lobe direction, which represents the desired signal propagation characteristics. And the opposite direction is backward direction in the case of directional antennas, which here the power radiated 180-degree from the main lobe. So if we take a ratio between these, we get the front to back ratio, which is usually represented in decibels, and it indicates the antenna's ability to reject signals from rear, critical, and interference mitigation. And the next characteristic is effective length. So we can see the physical length versus effective length. So effective length L effective represents the equivalent length of a uniform current distribution that produces the same far field radiation as the actual antenna. So this will be given by L effective is equal to integration of the length of the antenna 0 to L, Lz e power j kz cos theta dz by I naught. So now the testing part, we see radiation resistance. It is a fictitious resistance that would dissipate the same power when it is connected with the antenna input terminals radiated by the antenna when carrying the antenna current. So this is another important parameter in the case of antenna and wave propagation. So now we are coming to the application part. The impact of antenna parameters. There are so many applications. It will be useful in medical imaging, satellite communication to transmit and receive signals, radar technologies, communication systems, etc. And also we have seen the various parameters: gain, directivity, bandwidth, radiation pattern. So far we have analyzed so many antenna parameters, fundamental concepts, core parameters, electrical properties and applications. We have discussed about radiation intensity, radiation pattern, directivity and gain, front to back ratio, effective length, radiation resistance and bandwidth. References. Thank you.